Now let's do some practice problems related to arc length. So up on the top here, we've got our formula again. So arc length is the arc measure out of 360. In other words, the fraction of the circle times the circumference. So it's the fraction of the circumference. Now, as we do the problems, and I mentioned this in the last section, when we're working our way through formulaic problems, I would like you to go through the 4 steps of showing your work. So state the formula, plug in the given values, solve for the variable, state the final answer, including a label. So that's what we're going to do here. I want you to get used to modeling it that way. So we are now looking at the arc length of AB here, with a radius of 6 and an arc measure of 120 degrees. All right, so let's write down our formula here. So arc length is equal to the arc measure, so I'll just put arc degrees, out of 360 times the circumference, so times pi d. Now I'm just going to do the pi d through these problems because it makes things just a little bit easier to keep it just as 2 terms that we were multiplying instead of 2 times pi times radius. Okay, so arc length, which I'll now abbreviate A, I'll plug in our numbers. So we got 120 degrees out of 360 times pi times diameter. So the radius is 6. So that's a radius. So let's remember then the diameter would be 12. So another 6, so a total of 12 for the entire diameter. So pi times 12. All right, now it's just a matter of simplifying this. So arc length, 120 out of 360 is 1/3. And I'm just going to put the 12 next here, actually, 12 pi. So 1/3 times 12 pi. 1/3 of 12, 1/3 times 12 is 4 pi. So the arc length is 4 pi. Now, I don't think there's any specific units on this. It really should have some on this sheet, but we're going to make sure that we still include some sort of label here. So we're going to say 4 pi units, just generic units, which is approximately, if you multiply 4 times pi, about 12.6 units. Okay, so the exact answer is 4 pi, and the approximate answer rounded to the 10th place is 12.6. All right, so that's all there is to it. If we can just plug in our numbers and keep track of that formula on a basic problem, let's go through another one over here. This one, you're given the circumference is 24 pi, and the measure of the arc CD is 60 degrees. So arc is 60 degrees, circumference is 24 pi. Find the length of arc CD. It's a little hard to see here, but we want length of CD. All right, so once again, let's start off with our formula. And I'm just going to abbreviate arc length now as AL just to save some space. At is equal to the arc measure out of 360 times the circumference, so times pi d. All right, let's plug in what we know. We know that the arc measure right here is 60 degrees. So arc length is equal to 60 out of 360. Now, we're told the circumference is 24 pi. Remember, this calculation right here, pi d is the circumference. So if you're told that the circumference is 24 pi, that's what we're going to put into this spot, 24 pi. All right, good. So now let's just simplify. Arc length is equal to 1/6, 60 out of 360 is 1/6 times 24 pi. 1/6 of 24 pi, 1/6 times 24 is 4 pi. So actually it's the same answer as we had in the first problem. So that arc length is 4 pi units, which again is about 12.6 units. All right, so the only real twist on that problem was that you're given the circumference, which actually means you just put that whole thing in the circumference spot, because our calculation is arc measure out of 360 times the circumference. All right, number 3, we have given that the arc length of EF is 5 pi, find the radius. So this one's a little bit different because we're actually given the arc length. Now we're also told that this central angle here is 30 degrees, which means that our arc measure is 30 degrees also, so that is something we're given. And then the length is 5 pi, find the radius. All right. So let's go ahead and put in our formula. So arc length is the arc measure out of 360 times the circumference, so times pi d. I guess we're going to be solving for the radius, so we're eventually going to have to divide that by 2. All right, let's plug in what we have here. Now, what we have is the arc length, so we're actually going to put that in the arc length spot, right? Because that's what's given to us, 5 pi. And then we're given that the arc measure is 30. And then times pi d. We don't know the diameter here. We're solving for the radius, so that's actually what we're going to be getting by itself. So it's a little bit of an algebra problem now. The others were kind of order of operations, but let's simplify. Step number 3 is to work this through. So 5 pi is equal to 30 out of 360 is 1/12 times pi times d. All right, now we've got a little algebra to do here because we're going to try to get the diameter by itself and eventually state it as the radius. So let's start off by undoing the multiplication from both sides. So we can divide both sides by pi, and in this case, it actually cancels it out from both sides. So 5 is equal to 1/12 times the diameter. So now we have to undo the 1/12, which means that we're going to divide both sides by 1/12, which is the same thing as multiplying times the reciprocal, which is 12 over 1. So if we undo this division by multiplying by 12, then we'll have 12 over 12, which cancels out to 1. And so now we have the diameter by itself over here on the equation. Over here, 12 times 5 would be 60. So our diameter is 60. Our question was asking for the radius. The radius is half the diameter, so that would mean that the radius would be 30. And again, since there aren't any specific labels here, we will still write in units to get used to doing that work and showing